Hi everyone, Miss Donaldson here. We're going to continue with our Unit 3 with proportional and non-proportional relationships. When you're talking about proportional relationships, we're referring to when two or more quantities form equal ratios. As you guys know, ratios can be written as fractions, which we will see them this way in this unit. But when two fractions are equal, then we're saying that they form proportional relationships. There are three ways that you can represent a proportional relationship. The first way is a table, the second way is a graph, and the third way is an equation. This lesson we will go into more detail into looking at these three representations and deciding if they're proportional or non-proportional. Let's first look at a table. Now, as I continue the video, if you guys would grab your organizer, the Venn diagram. As I fill this out, you guys need to find the corresponding section in your organizer and complete. We're going to start in the proportional section first, and then we will go to non-proportional. The first section we're going to look at is in a table to identify proportional relationships. In a table, basically, guys, you compare your X and your Y points. We're going to get in more detail about this later, but really when I say X and Y in a situation, X and Y actually represents an ordered pair or a X coordinate and Y coordinate. So in the table here, you guys see I have X and I have Y. My X's are 1, 2, and 3. Again, though they're in the table listed as 1, 2, and 3, these are really X coordinates. An X coordinate of 1, an X coordinate of 2, and an X coordinate of 3. On the other hand, I have Y. 4, 8, and 12. Again, although they're listed out in the table as 4, 8, and 12, these are really Y coordinate of 4, a Y coordinate of 8, and a Y coordinate of 12. And the X and Y paired together, how I have the 1 and 4, that is really an ordered pair. We're going to look at that, like I said, in the next section to talk about how we transfer those to a graph to determine proportional and non-proportional. But anywho, let's keep going. Table. If I have tables, I'm looking for my points should form equal ratios. Now, when I set up my ratios, you set them up as Y over X. So I'm going to take each set of points in my table and I'm going to set them up Y over X. So the first set was 4 over 1. If I look there, that is already a simplest form. Although, guys, it is an improper fraction, for now, I'm going to leave it that way because it's going to actually end up telling me my constant. Again, that's the word we're going to use later on, and you will also use in 8th grade. The next set, Y over X, I go 8 over 2. Again, I realize that's improper, but I still want to keep it that way. 8 and 2 share a common factor, which is 2. I'm going to divide them both by 2, and I get 4 over 1. If you'll notice, 4 over 1, 4 over 1, so far I have the same exact ratio. So now I'm going to take my last set and go Y over X, which is 12 over 3. If I divide them both by 3, then I'm going to get 4 over 1. So I'm going to let's look at example number 2. Now, if you notice, instead of the table being vertical, this table is not horizontal. So, but I'm still going to set my proportion up, my ratio up the same exact way. I'm going to go y over x. So I'm going to take each set of points and I'm going to go y over x. So if the first set, my y is 3 and my x is 2. My next set, I'm going to circle that. So that's my next one. It's going to be 6 over 4. They share a common factor, which is 2, and I get 3 over 2. So far, I'm forming the same ratio. Y over x, that's going to give me 9 over 6. They share the common factor of 3. And again, guys, you should notice I'm getting 3 over 2. If this last one forms the same ratio, then I know that this table represents a proportional relationship. I'm going to go 9 over 12. Again, this one shares 3. And I get 4 over 3. Now, guys, let's look and see what we notice. They're always 3 over 2 except for the last one. The last one ended up being 4 over 3. Since they all did not share the same ratio, then this makes this example a non-proportional relationship. It doesn't matter that 3 out of the 4 were the same. Since that last one was different, then that makes the entire table not be proportional. So let's go through and let's define non-proportional. Non-proportional would be, non-proportional, that would be when that would be when my ratios do not form equal fractions. So again, if they're not equal fractions, doesn't matter if they all are except for one, they all are not the same, so it's going to be non-proportional. Next, let's look at proportional relationships in graphs. As you guys know, when you're graphing, you're looking at your x and your y. Again, that is the reason why I kept mentioning in the section before that in your table, your x and y are actually ordered pairs, because you can actually take those set of ordered pairs in your table and graph them, and it will demonstrate through the graph whether it is proportional or non-proportional. If you're looking at graphs, you know that a graph is proportional if they form straight lines. So here I have 2 examples. I have a line that is increasing up, and I have a line that is increasing down. I'm going to go ahead and throw in some 8th grade stuff. The line that is increasing up is said to have a positive slope, or again, a constant rate. So it is increasing at a constant rate. The one that is increasing down, again, throwing in 8th grade stuff, is said to have a negative slope. Or in other words, it is decreasing at a constant rate. So it doesn't matter if it's going up or going down. If my line forms a straight line, then I know that it's going to be proportional. Now, let's take a look at graphs compared to non-proportional. So if graphs that form a straight line are proportional, then on the other hand, graphs that do not form a straight line, then they're going to be non-proportional. So here I have 4 examples of different lines that do not form a straight line. These are not, I'm not saying these are the only ones you can see. You may see others. But if my line is not consistent, straight throughout, then it will not be a proportional relationship. So again, to recap, for graphs, if it forms a straight line, it will be proportional. If it does not form a straight line, then it will be non-proportional. The third way that you'll be able to see a relationship with proportional or non-proportional will be through an equation. When you're talking about proportional relationships, we are looking for an equation in the form of y equals kx. Now, we're going to get in more detail about this in the next video or our next standard, but I kind of want to go ahead and preview for you. When I say y, again, that goes back to that y coordinate. When I say k, that's referring to your constant. And then your x will be your x coordinate. So basically, guys, you're looking for a number, looking for y, an equal sign, a coefficient or number that's right beside a variable x. It could be a whole number, it could be a fraction, it could be a negative number, it could be a negative fraction. But again, it has to be in the form of y equals kx. The examples below are all examples of proportional relationships because they were in the form of y equals kx. I'm going to go through and circle these numbers here. The 4, the -5, the -1.5, the 2/3, and -1/4. Again, those are my constants, or those are the coefficient of x. Again, when they're in that form, that lets me know that they are proportional relationships. So, on the other hand, if equations that are in y equals kx are proportional, then the ones that are not in that form will be non-proportional. So I have 4 examples here that are non-proportional. So the y equals 4 squared x. Again, that is non-proportional. The y equals 3x cubed. Yes, that 3 is there, but since that x is cubed, then that's going to be non-proportional because it is not in the form of y equals kx. Y equals x squared plus 4. Y equals the square root, of 2x cubed. Again, they are not in the form of y equals kx. So again, guys, let's wrap this up. Proportional relationships is when you're comparing two quantities and they form equal ratios or equal fractions. Remember, there are 3 ways you can represent a proportional relationship or non-proportional. We can see it in a table, we can see it in a graph, you can see it in an equation. Remember, in a table, you pull out each set of those points, x and y, you set them up as y over x. If your ratios, when they're simplified, form the same ratio or the same equivalent fraction, then it is said that they are proportional. If they do not form the same ratio, again, it doesn't matter if they all form except for 1, then it's going to be non-proportional. Second, graph. Your graph must form a straight line for it to be proportional. If your graph does not form a straight line, then it is going to be called non-proportional. And then the last way we're going to look at relationships is through equations. If your equations are in the form y equals kx, where y is your y coordinate, k is your constant, x is your x coordinate. If it's in that form, then it's going to be proportional. If it's not in that form, then it is not proportional. Alright, guys, so I hope this has helped you. If you need to go back, rewind, do what you need to do. After doing this, I want you guys to work on your iBook sorting test. Instructions are there, and I will talk to you guys later.